So we
Sir, before you start,
okay.
sir, are you sure that the highest got 68?
Yes.
Too bad.
There's a question which are the 12 marks. Another one are the
And so when I was going to know the results.
No, I think Mr. Kunda is posting in your inbox one by one.
There's nothing yet.
Yeah, you'll post this one. Okay. So after binomial, there will be no test. We'll do trigonometry. After trig, since now the topics will be 5, we can have we will now start sampling exams.
So what of calculus?
Calculus will come after trig. I mean after log, then we'll calculus. So just a week from there.
All right.
So we did this, came up with this. N minus 1 B plus N minus 2 B2 N minus 3 B3 N minus R BR. It keeps going. Now we also had examples where we use the Pascals and also use this, got the same solutions. We also had examples where after we solved for the coefficients here, another thing came out to be an plus n minus 1b plus n minus 1 over 2 an minus 2 b2 plus n minus 1 n minus 2 over 3 factorial an minus 3 b3. Now, just here, you can be asked to show that. So I want to start talking about identities. Just here, you can be asked to show that 1 n choose 0 plus n choose 1 plus n choose 2 plus n choose 3 plus n choose n is equal to 2 power n. From this expansion, you can see that this actually is a very easy task if you know how to select your A and B. Okay, the A and B required is that A and that B that will not affect the coefficients, the n choose 0, the n choose 1, the n choose 2, but it will be there and yet look like it's not there. But the other side, it must give us a 2. Now the options that takes us to 2, we have 2 plus 0. So we have, it's okay. So we have 1 plus 1. We also have 2 plus 0. We have 3 minus 1. We have 4 minus 2. But if you look at these other combinations, they will require that where there is A there, if we have to have 2, then we should multiply n to 0 by 2 to the power n. That can only work if we know what n is. Now, before we know what n is, if we select 1 and 1 to the power n, we'll have n0. Where there is a, we'll put 1 to the power n. We'll have n1. We'll put 1 n minus 1 multiplied by 1. We'll have n2. We'll put 1 multiplied by n minus 2, 1, 2. We'll have n3. We'll put 1 n minus 3, 1, 3. We'll keep going until we get to nn, where there'll be 1 to the power n again. But the good news is that 1 plus 1 is 2. So we have found 2 power n. And 1 to power n is still 1, even if we don't know what n is. So we get n0 plus n1 plus n2 plus n3. You keep adding until you reach nn. And this is what is required. So when they say prove this, and you see 4 marks, or you see 2 marks, or you see 5 marks, let it be a sure thing that you're getting those marks.
Sir, can you repeat?
So when you have 1 power 1, 1 power 1 is the same as 1 power 2, which is the same as 1 power 0, which is the same as 1 power 3, 1 power n. That's where the secret is. And after having 1 power n multiplied by n choose n. Of course, I'll get n choose n. So if the choice of A and B makes sense, if you choose 1 and 1 for A and B, when you add them, you get 2 to the power n, and then go in the binomial theorem where there is A, take 1, where there is B, take 1. Place the powers in the same way they are placed in the formula. When you evaluate, you remain with just the coefficients, as it is here.
Sir,
Hello?
kindly explain.
Okay. So if there was to be another way, that's when you should be worried. Say, how do I know that it is this way and not the other? In this case, your eyes are on this number. Since there's a 2 the other side to the power n, and on the left, I only have the coefficients of the binomial theorem. N choose 0, n choose 1. Where is a power n? Where is a power n minus 1? Where is b? So where are these products for this thing to appear in this form? Okay, then you come this side, you find there is 2. Then you know, oh, okay. This means that since 2 is the same as 1 plus 1, it could be that where there is A, we should have 1. Where there is B, we should have 1. In brackets to the power n, so that when we add, we get 2 power n. Will be equal to n choose 0 multiplied by a power n. A is 1, so it will be 1 power n, plus n choose 1 multiplied by a power n minus 1, but we have said a is 1, so it will be 1 to the power n minus 1. Where there is b, we have 1. When you're multiplying 1 to the power n minus 1 by 1, you get 1. That is just 1. Once I get 1, I multiply by this coefficient. Even if I don't know what this coefficient is, I know I'll get that coefficient, because a multiplied by 1 is just a. Anything you multiply by 1 is just that thing. So all the coefficients will come down because they're being multiplied by 1. So you have your identity. Okay. So when you are still thinking about what to ask, let me give you another. Show that n choose 1 plus n choose 3 plus n choose 5 all the way up to n minus 1 is the same as n choose 0 plus n choose 2 plus n choose 4 plus n choose n if n is even. Again, back to the binomial theorem. A plus b to the power n is n choose 0, an is n choose 1, an minus 1b it's n choose 2, an minus 2b squared is n choose 3, an minus 3b3 it's n minus 1, bn minus 1 it's n bn. That's the expansion. Say, okay, if this is the binomial theorem, and we are told n is even, and we have the odd the odd numbered coefficients down here are on their own, because if n is even, then n minus 1 is odd. An even number, for example, 4. 4 minus 1 is 3. 3 is odd. So this is n, this is n. So you have n even, n minus 1 will be odd. If you have 6, then 6 minus 1 is 5. 5 is odd. So that we notice that, okay, so all the coefficients with odd numbers down are on their own, equal to the coefficients with even numbers. What does it mean? It means that our choice of A and B should be in such a way that when we separate these two, they will be equal. In other words, it should give us an opportunity where the other numbers are negatives, so that when taken the other side, they'll be positive. And that side there should be 0, because there's nothing else here apart from the coefficients, meaning that there was a 0 before they came this side. So what do? We make a good choice.
I don't understand just there.
Okay, you understand when we tick the numbers. So don't worry, good son. Let's pick the numbers, then you see. So we are saying, since
Maybe the numbers make some sense soon.
yes. So for us to have that equality there, where there is A, if you notice here, we used 1 and 1, and we had all the coefficients positives. On the other side, the 2 power n. Now we want the other side to have a 0. So we'll pick 1 minus 1 to the power n. This will give us n to 0. A is 1 power n plus n choose 1. A is 1 power n minus 1. B is negative 1 plus n choose 2. A is 1 power n minus 2. B is negative 1. It's being squared plus n3 A is 1 power n minus 3. B is -1. You go all the way up to n minus 1. A, it's just A multiplied by -1 to the power n minus 1 plus n choose n. Only B appears here to the power n. Now remember, n is even. So -1 squared is +1. -1 power 4 is 1 because these numbers are even. This means that -1 power n, when n is even, will get 1 there. So because we have such a situation, this means that 1 minus 1, this is just 0. 0 power n is still 0. Then we get n 0. This is being multiplied by 1 power n, which is just 1. Here now we will have negative n choose 1. This is because 1 power n minus 1 is 1. 1 by -1 is -1. -1 by n choose 1 is just negative n choose 1. Plus, because the negative is being squared, and the 1 to n power is still 1. So we just get n choose 2. So the pattern comes, -1 power 3 is negative n choose 3 plus n choose 4. If there's n negative, the next one plus, you could keep going until you get to minus n minus 1 plus n like this. Since you understand that -1 to the power n minus 1 is going to be -1 because this number is odd. Like we have -1 power 3. This is just -1 squared multiplied by -1. So we get 1 by -1, which is -1.
Sir,
Hello.
maybe if you can write what you are saying so that I'm confused.
I'm also lost. I don't in the beginning.
Oh, you will not see it.
Like, sir, here where there's where you're saying on just the equation for the expression, the second expression where you said a plus b close brackets n is equal to this. Then the last part you have said n choose n minus 1, a times b n minus 1. How was it like that? And why are we equating to 0 again? And this thing that you're talking about, like odd, so it's even. Yes, sir.
Where does the even odd thing come from? The question is saying, show that, remember, look, the question says, show that. This is the question here. Show that 1, we have shown. 2, that n choose 1 plus n choose 3 plus n choose 5 plus ... plus n choose n minus 1 is going to be n choose 0 to be equal to n choose 0 plus n choose 2 plus n choose 4 all the way up to n choose n if n is even. Now we're trying to figure out what it means to be even. When a number is even and you're dealing with a negative, realize that a negative number to the power even, you get positive. And if it is 1 then -1 to the power even will come out to be +1. Our question just has coefficients. This means that the choice of A and B is like what we had here, where for you to preserve the coefficients, you choose A to be 1, B to be 1. But in this case, the coefficients are equated, some coefficients are equated to the other coefficients. There's nothing else involved here, meaning that our choice of A and B should also be in such a way that we are able to separate these two types of coefficients using the word even. The opposite of even is odd. So since we can see that in the question, the numbers on the left, the numbers down here are odd. And on the right, the numbers down here are even. What will save us is making the same choice, but one should be negative. And then, how do you come up with this? When you are doing binomial, the first thing to know after you do Pascal's triangle is to make sure if you are spending the whole day, spend the whole day knowing the binomial theorem. And this is the binomial theorem. When we say plus ... there are so many terms here that if you want to add after 3, the next term will be n4. A n minus 4, B 4. This number here becomes the power of B. So if you keep going until the second last number, since the last number is nn, B power n, the next last number should have n minus 1 down, so that when we move, you move to n. On top, it's still n. So it means that because the numbers makes a pivot, you saw that when we are dealing with the Pascal's triangle, we had something like this. We had this 5, 10, 10, 5, 1. You have 6, 15, 20, 15, 6, 1. So there's always a center and you are going down as you can. Even the powers behave the same way. The powers of A go down. So if we are doing A plus B power 6, the powers of A, we are now in this line. We have A power 6 plus 6A power 5, B power 1 plus 15A power 4, B power 2. So B is picking 20A power 3, B power 3. 15A power 2, B power 4 plus 6A power 1, B power 5 plus B power 6. So the powers of B are increasing as the powers of A are decreasing. Now, because they are decreasing, the second last number here will have this power here, 6 minus 1. And this one will be the power of A. That's what we have here. N minus 1. And A has power 1. It is coming from the binomial theorem. If we put that second last term, the terms of the binomial are only put when they are to be used. Because there are so many, because no one knows what n is. So when you are given the information about n, you only get to use that information without knowing what the n is. Here we've just been told if n is even. So to appreciate the even part, we just know that if whatever we're going to do will involve some negatives, we must remember that if we meet n as a power, it will be even, so the negative will be neutralized. That's the more reason why when you make a choice of A to be 1, B to be -1, as you substitute in your expansion, because what is happening here is just substituting. A is 1. So wherever there is A, I have 1, 1, 1, 1, 1. Now 1 power anything, we are saying it is 1. So that must not worry us. B is -1. So wherever there is B, I'll put -1. Wherever there is B, I 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 put -1. But -1 power 2 is just 1. -1, when it's standing around like that, nothing else is negative. So we have this thing multiplied by -1, we have n choose 1 to be negative. Here there's no negative, so I just placed n choose 0. This 0 is coming from the choice of A to be 1, B to be -1. So 1 minus 1 is 0. 0 power n is 0. Even if you don't know what n is, and even if n is even, if we have 0 power that n, it will be 0. Then now you go on. So n choose 0 gives us n choose 0. N choose 1 multiplied by a negative, we have negative n choose 1. N choose 2 multiplied by -1 squared, that is just +1. So +1 times n choose 2, we get n choose 2. N choose 3 multiplied by 1 power n minus 3, this is just 1. -1 power 3, it's -1. So -1 times n choose 3, we get -n choose 3. So the next number, if it was to be there, it would look like this. N choose 4. 1 power n minus 4. -1 power 4. -1 power 4 is +1. 1 times +1, you get 1. 1 times n choose 4, we get n choose 4. The next one will be 5 here. So if you have 5 here, then you should have 5 here. -1 power 5, that is negative. So you have n choose 5. Plus, you keep going. Since n is even, we are saying n minus 1. Since n is even, n minus 1 is odd. Okay. So where are you taking? Someone saying, help me understand where n minus 1 is going. Where 1, n minus 2 is going. N minus 3. These n's minus 3, n minus 2, n minus 1. These are the powers of 1. Now we are saying 1 raised to any power, it will be 1. This is the power of 1. What is 2 squared? 2 squared is 2 times 2, giving us 4. Where has 2 gone? It has told us to multiply 2 by itself. So if it was 2 power n minus 1, we would do nothing because we don't know what n is. Here we are using the property of 1 1 multiplied by n, we're saying, I mean 1 power n, 1 times 1 times 1 times 1 up to 1n, I mean up to n ones, we'll still get 1. That's why those n minus 1, n minus 2, n minus 3 disappear in the next step because they're just the powers of 1, which doesn't care. 1 to n power is still 1. I hope you understand that. Angel.
Yes, I understand the expansion. Now, the only part that's confusing me is the choice of A and B that you were talking about.
So to choose A and B, you look at how the question has been phrased. So your choice of A and B should produce, look, in our proof here, we have nothing else apart from the coefficients. So you choose A and B, that will affect your coefficients in the way you want them to be affected. In the previous proof, we had 2 power n equated to the coefficients. So we knew that what to do here is to just play around with the A and B so that on the right-hand side of the expansion, there will be no A and B. On the left, will remain with a 2. So why are you using 1 minus 1? You're using 1 minus 1 because you want now at this step, we are taking now the negatives, we take them the other side. So we'll have n1, n negative when it crosses the equal sign it becomes positive. So plus n3, again it becomes positive, n5. You can keep going having the positives, n minus 1. Even that was negative on the right becomes negative on the, becomes positive on the left. And then the positive ones remain positive because they have not gone to any other side. They have maintained their side.
Sir, I have a question.
Okay.
So, sir, there on question number 1, because you're proving to n. So is it that yes, here where you added 1 plus 1,
Yes.
is it that because of the 2 is given 2 to the power n or what?
It's because of the 2.
Of the 2, so that when you add 1 plus 1, it will give you it will take you back to the 2 to the power n.
Yes.
Now, in the case whereby it's not 2 here, where you can say 1 plus 1, where let's say you have 4, how can you do it?
They can't give you 4. If they give you 4, you will see it also in the coefficients appearing. Whatever alterations that are there, they will be visible. Here, we know it can't be 1 plus 1. Because if it is to be 1 plus 1, then we must have a 2 somewhere to the power n. Now there's no 2 to the power n, there's only the coefficients. So you know your choice cannot be 1 plus 1. Your choice should be 1 minus 1, so that the other side, there will be 0. So that when you take the number the other side, it will make sense.
Sir,
I'm
really sorry to ask, but I just have to ask.
Yeah, you're very free to ask.
Like, how did you see it the way you have seen it? Like, how did you understand it in a manner that you figured out that I'll just use a 0, then everything will come out like this?
Not a 0. I'll use A as 1, B -1. Okay, now we've run out of
so
time.
whenever you
The 40 minutes will be cutting end time soon. So immediately it cuts, you log back. And we'll do a similar proof to this one.
whenever you have an identity like this, you have to think about A and B.
Yes.
What will be your A and B?
Yeah, that's what we always think about. The n minus 1,
Okay.
n minus 2, these are the powers.
Okay. Thank you.
Okay.